The next report will come from the Racing Surfaces Committee. Dr. Mick Peterson is a professor of mechanical engineering at the University of Maine. He and Dr. McElraith have been working on racetrack surfaces through a grant from the American Quarter Horse Association several years ago, before the advent of more synthetic surfaces made the subject, perhaps you could call it more complicated or also more exciting. So Dr. Peterson is really in the front line of the science of maintaining racing surfaces. Dr. Mick Peterson.
Okay, thanks a lot. I'll make this quick since I was supposed to finish 10 minutes ago. As with the other committees, we've got a broad number of stakeholders and researchers that have been involved in this, and I won't go through the list, but to give you an idea, we've got trainers and we've got a broad representation of the training and ownership of tracks. I'm going to start out with the recommendations that we came out, and I have the wrong date on here, but here's the welfare and safety of the Racehorse Summit. And the big thing was the inconsistency of the racetrack surfaces was a concern for a number of the people who were there. And the recommendation for action is racetrack surface examination and certification process. Basically, when you ship into a track or when a horse comes into a track, there's some confidence that you know that track is going to be safe and is going to be consistent. The other thing is you see this common theme of surface research and also the workshops. The primary objective too, these all make sense in the broader context of the final report from the last summit, but the data gathering. And the data gathering obviously ties very closely to what Dr. Scolet has been talking about on theirs on the injuries, the same sort of a process going on for the surfaces. And it's very important to begin to bring this information into a form where it's quantitative and it can be used in order to improve the overall management of the racetrack and the surfaces. Okay, where's the status today? We've really got three areas we're looking at: measurement methods, and these we really have to separate out into synthetic and dirt, although there's some overlap. I tend to leave turf out of here because that's just one more complexity. You have to have something green growing on the surface as well as having it be safe. So I've avoided that, although it's obviously in the mix. Maintenance reporting system, and then also research on the materials, and this has become with the synthetics a very hot topic. Before I talk about surfaces, though, I always have to have at least one slide in there or one mention of tracks in general. I think very few people can argue with the fact that tracks have improved over the past century. I have this collection of old pictures of races, and look, this is a decent race. You can tell it's a long time ago just looking at the crowds there in the stands, you know, with the 50,000 people there. And look what they didn't do. They didn't even harrow before the race, you know, so things have definitely changed. You know, at least you harrow before every race, and this was common. And the risk to the horse is multifactorial. So the tracks didn't cause the problem, it's important to say, but they can help improve the situation. Where are we at now? We've got the measurement methods. We have synthetic surfaces. We do not have engineered surfaces. We need to learn how to measure both the track material, which is the composition, and we know these materials change over time. We need to have maintenance procedures, and we need to be able to compare the materials on different tracks. And then we've got the properties of the tracks, and this is the performance. This is what we've been focusing on from the very beginning. We really need to be able to compare tracks so there are going to always be dirt surfaces, there are always going to be synthetic surfaces now in the mix, and we need to be able to know that both of these surfaces are safe for the horse. The measurement methods, as I mentioned, have got the performance, the biomechanical hoof that we've been working on for a number of years, and then also just other measurements of shear and modulus. The shear is basically the speed of the track. The modulus is how hard it is when the horse comes down on it. But then once you know the performance of the track, then obviously you get to ask the question, how to fix it? What is the composition? The other issue that comes into this is base problems. The ground penetrating radar is an option for that, and then maintenance protocols. This is huge, and we've seen this in the synthetic track area, is the maintenance protocols, and I'm sure that's what's going to be the focus primarily of the superintendent's discussion later on. And then also the composition. We have a pretty good idea of what's going on in the organic tracks. We've got moisture, organic material. We've now started using X-ray diffraction to do the clay mineralogy. In the synthetic tracks, we're just really at the beginning stage of this, looking at the fiber volume, the wax composition in the rubber, and other composition ashes. Here's the big picture. This is kind of scary, especially we've got a couple of these that we're working on that are progressing. But if we look at track management and engineered track management, we have the composition. Let's see, that would be on your left, the composition. And we have to separate that out in the dirt and synthetic. Some of these things are happening. And then we've got the performance testing. This needs to be done on all tracks because all tracks need to be safe for the horse. Looking at this in a little detail, if we look at the synthetic composition, this is clearly an area that needs work. Polytrack has funded some work for wax composition testing. Up until recently, we didn't have a standard procedure for measuring the amount of wax on the track, and it changes over time. The temperature sensitivity, it looks like there's new funding for that, and there's discussion with 2 other track manufacturers to begin to look at the sensitivity of these surfaces to tracks, the sensitivity of these surfaces to variation in temperature. It also, as I'll come back to, I think even with the synthetic tracks, we have to put the moisture sensitivity in there as well. There's also been, in California, quite a bit of discussion of the permeability testing and coming up with some standard permeability testings for the synthetic and traditional tracks. The performance is a little better developed at this point. They're not broadly used, but we're at least to the point where we're beginning to know some of the issues that show up on the performance methods, measurements. They're not used at all tracks, although at this point we're getting to the point where some of the tracks are doing at least an annual checkup sort of a thing. We've got the biomechanical hoof that QHA originally supported the development of, ground penetrating radar, where Dolly Green and Oak Tree Foundation. The temperature and moisture stability obviously needs more work. The second area is the maintenance reporting system. This is where there's a lot of overlap with this work that Dr. Scollet is doing, and then also the work that Jeff and Wayne are going to talk about related to soft tissue. We kind of have to, in this area, start with the possible and move on to what's more of the ideal. Current best practices, their turfway and some other tracks have a spreadsheet essentially that they're keeping day in and day out, where they at least keep track of what kind of maintenance is performed day in and day out. That's something that can be rolled out immediately and used much more broadly in the industry, and we're working on that at this point. The expanded system takes basic information where tracks would have information at the start of every meet, and periodically as any kind of changes occur. And this may just be, for a dirt track, this may just be particle size separation, the amount of organic, they know where they start. All tracks would then use a 1 line per day system. Then what I'm calling kind of the class 1 monitoring. That's where we use established measurement techniques to monitor things that we know matter: temperature, moisture, track depth, using Clegg hammer or possibly a shear vane or dynamic penetrometer to get some numbers on there. All of these are flawed and they're limited, but if they're done each day, we can begin to track over time what's changing. Then the obvious things. We also need to look at the weather data and the injury and performance data. Once we begin to link the information that we know to the injury and performance data, I'm talking about race times and that sort of information. Once we begin to link what we know to what the outcomes are, we begin to be able to track over time the changes. The next stage then on the maintenance reporting system would be an on-site performance monitoring, where there would be a set of numbers that, based on research, that we know they relate to the safety of the horse. Then we can take the daily measurement of the performance and periodic measurement of composition, put that into a database that can be linked completely to the epidemiological data, and that's where we begin to actually affect the health of the horse by knowing what we're doing from a maintenance. The third area is the research on the track materials. Some of the data we've come up with over the last few years begins to make sense. Clay and sand mineralogy, those are X-ray diffraction curves on the right-hand side. It's not like I'm asking you to interpret those. But Everything we've done with the X-ray diffraction, it's just verified that the superintendents, for the most part, knew what they were doing. If they had different procedures, they were actually responding to existing clay mineralogy in the area. It was really nothing new. There was no real clay in the East Coast tracks. They had a different maintenance protocol than the West Coast tracks. The West Coast tracks had clay. They had to maintain the surfaces differently. Some of the stuff is fairly mindless. We have 2 sand samples from 2 different surfaces. Those are the pictures of the two sand samples from the 2 different surfaces, and they got different outcomes. It's not like there's a big surprise when you have that kind of a shape and mineralogy difference between the two sand particles that you'd receive, that you'd get a different outcome. So some of this is pretty straightforward. On the other hand, there's significant research needs. This is repeatable data, and this is from a synthetic surface that's being used at a training center. We've heard extensive information about the sensitivity of synthetic tracks to temperature and the insensitivity of them to water. What we see here is at the left and right, we've got a low wax track and a high wax track, and we've got a moderate wax composition track under 3 different conditions in the middle. One's at low temperature, one's at a higher temperature, and one's with water. The water has a dramatic difference, almost as much of a difference as addition of wax. Is this a result of the sand that we use in that particular material? Was it the fiber content? There are a lot of variables. What we do know is that some of the folklore that's associated with the synthetic tracks is not being borne out in controlled labs. So we're saying suddenly this information, that database that I had that said that we needed to be really careful of temperature on synthetic tracks, it's like we better be monitoring moisture content at the same time. So there's a lot of fundamental research that needs to go into this, but building then into a database very much like the injury database. So the future, we need to continue to work on the measurement methods. You know, fill out that matrix of tests, the slide there with all the little boxes with only a few circles. And we need to begin to develop the network that's capable of doing these tests. The maintenance reporting system, starting out with 1 line per day, develop a culture of data for the track maintenance, and to begin to track effects. This is where we can begin, even with a simple maintenance program, to join that to the injury system and see if we begin to see correlations between that. And then we need to continue the research on materials. And most critical here is, because of the very finite resources that are invested in this, is make sure that we coordinate whatever investment is made in the research on the track surfaces so that there's minimal duplication but verification of the work that's being done, which is a continuing challenge in this industry. Thanks a lot.